Alright, I'm going to do problem 12 from chapter 34, which basically wants you to take this equation and plug it into this differential equation and verify that it's the solution. They want you to do the same thing for the magnetic field. This is the electric. They want you to do it also for magnetic, but it's going to end up being the exact same because the only thing different about the magnetic field is that instead of E's, there are B's. Everything else is the exact same in both equations. So I'm just going to do it for one, and that works for both. Basically, just start by getting these partial derivatives. That ends up being this. And then the second partial derivative will equal and then you do it with respect to time, because that's the other part. We did this one, I'll do this one. And that will, I'm just going to go straight to the second, because it's kind of the same. Well, Tmax. And then basically, it's saying that the second partial derivative with respect to x is equal to these two constants times this second derivative with respect to time. So you just set them equal to each other. Negative. Well, that kind of got jumbled up there, but it doesn't matter because that's going to divide out on both sides, and so will the negatives, and that will leave this. And then from that, we know that this is the angular wave number, which is 2 pi over lambda, and W is the angular frequency, that's 2 pi f. So that ends up being 4 pi squared, lambda squared, the 4 pi's are going to go away, 4 pi squared. And then we have 1 over lambda squared equals mu naught, this little e naught, frequency squared. So that can be rewritten like this. That's just with algebra. And then the square root of that is that. And we know that the frequency times the wavelength, which is what that is the wave speed. And because we're dealing with electromagnetic waves, the wave speed is the speed of light. And this little thing right here, the square root of 1 over the product of these two constants, comes out to be the speed of light in a vacuum, which proves that this equation for electric field or magnetic field is a solution to this differential equation.